Hey, what's going on, guys? Let's do this problem right here. This question is asking to find a power series representation for f of x is equal to tan inverse 2x. Now let's see how we can find it. So first of all, the first thing to notice is if you take the derivative for this one, tan inverse 2x, that's going to be equivalent to 1 over, actually 2 over, if you take derivative, that's going to be 2 over 1 plus 4x square, right? We need this pattern because we know that when we have 1 over 1 minus x pattern, it's easy to write the power series because whatever the value we are subtracting is going to be the power. So we are going to have x power n is equal to 0 to infinity. So this is the general pattern to derive. Now let's see how we can use this one to find this derive this power series pattern. Now we have this one, and if we want to get this one back, we can integrate this one. If you integrate 2 over 1 plus 4x square dx, you will get this one back, that is tan inverse 2x. But here, since we don't have any limits of integration, we are going to have constant 2, right? So here, now let's see how we can bring this pattern. So in the numerator we have 1, so we have to bring the same 1 right here. So if I want to bring 1, we can take this 2 outside. So this is going to be 2 integration 1 over 1 plus 4x square dx. Now whatever the value we are subtracting is going to be powered by n. So here we have plus. So if you want to write this one in subtracting pattern, you can write this one as 1 minus 4x square. So here minus 4x square is the one that's subtracting. So that's going to be the power series representation. Now if I want to write this one in power series representation, this is going to be 2 times integral summation of n is equal to 0 to infinity, and this is the value we are going to get. So minus 4x square power n, right? So this is our power series representation and dx. Now we can expand this one. So if we expand this one, this is going to be equivalent to 2 integral n is equal to 0 to infinity and minus 4 power n x power 2n dx. Now let's go ahead and simplify a little more, because we can bring this 2 inside, right? But before I do that, so what we can do is, this is we can integrate this one out. So if we integrate this one, this is going to be 2 times negative 4 power n, and all we are going to do is, and we are also going to have summation notation. So summation n is equal to 0 to infinity and then minus 4 power n x power 2n. So if we integrate, only this value will change, 2n plus 1 over whatever the power we are having, we are going to divide by this. So this is going to be, in the denominator we are going to have 2n plus 1. So this is going to be the integration. Now this is equivalent to tan inverse 2x plus c, but in the original question we don't have plus c right here. So we have to find out c and then subtract this one, right? So let's write this one in this pattern. So we know that tan inverse 2x plus c is equivalent to this one, 2 times sigma n is equal to 0 to infinity minus 4 power n x power 2n plus 1 over 2n plus 1. So here, if you want to find c, the easiest way to do is we substitute 0 for everything, 0 for x values. So if you substitute 0 right here, this is going to be tan inverse 0 plus constant, that is equivalent to, if you apply 0 right here, 0 power 2n, so anything is going to be 0, and 0 multiplied by anything is going to be 0, and you will get 0 right here. And tan inverse 0 is also 0. So this is 0 plus c is equal to 0. Therefore c is equivalent to 0. So if c is equivalent to 0, we don't have to change anything. This is going to be our answer. But here we can do one more thing. So here we can write the same thing as, so we know that c is equal to 0. Let's write this one on top. C is equivalent to 0, right? So now this is going to be our, so tan inverse 2x is equivalent to this one, 2 over this value. Now let's write this one more time. N is equal to 0 to infinity minus 4 power n x power 2n plus 1 over 2n plus 1. Now we have to simplify this one. So here what we can do is, we can write this one as 2 times sigma n is equal to 0 to infinity. I can take the minus 1 to the front. This is negative 4 power x, n. So we can take the minus 1 front. So this is going to be minus 1 power n, 4 power n, x power 2n plus 1 over 2n plus 1. Now again, sorry. So again, if you have 4 power n, you can write this one as 2 power 2n, right? X power n 2n plus 1 over 2n plus 1, and then we have minus 1 power n, and now we can take this 2 to the front. So if you bring this one to the front, it's going to be just plus 1 right here. So this is going to be our final answer. So here we have 2n plus 1. So sigma n is equal to 0 to infinity minus power 1 power n, 2 power 2n plus 1, x power 2n plus 1 over 2n plus 1. That's going to be our final answer. I hope you guys find this video helpful. See you next time.